Hello students, welcome once again to my channel, and we have another problem over here. So we have to evaluate this integral. So let's quickly start. Now with this integral also, since if you look at the denominator, you can see that we have integrand, and therefore we have to use the partial fraction. So what we are going to do now is that we are going to take the numerator and the denominator, then we take them through the partial fraction step. So we have 8 plus t plus 6t squared minus 12t cubed, then divided by 3t squared plus 4t, then t that. So writing the partial fraction, we have 8t plus b. Now remember, it is 3t squared plus 4, so 8t plus b. Looking at how it is written, write it the same way here. So 3t squared plus 4. Then we have ct plus, let's say, d. Then we can have also t squared plus 7 here. All right, so what we are going to do now is to simplify that. So we can have 8 plus t squared, then also plus 6t squared minus 12t cubed, then equal to 8t plus b will be multiplied by that t squared plus 7, then also ct plus d will also be multiplied by 3t squared plus 4. So now this is what we have. Let's expand that. So we have 8 plus t squared plus 6t squared minus 12t cubed. Now because of space, I've shrunk it to this place. So now let's expand. So 8t multiplies t squared, we have 8t cube, then 8t multiplies 7, then we have plus 7t. So we have 7, so let's say 780, then also b multiplies that, then we have bt squared, then also b multiplies 7, then we have 7b. Then over here we have ct multiplies 3t squared, then we have 3ct cubed. Ct multiplies 4 here, and we have 4ct. Then d multiplies that, we have 3dt squared, then we have 4d. Now this is what we have. So let's group like terms. So we have 8 plus t plus t squared plus 6t. Okay, so there is nothing. You look at the question here, 8 plus t, then plus 6t squared, so there's nothing like that, sorry. And this is out. So we have 8 plus t, then plus 6t squared minus 12t cubed equal to, now we're going to group items based on their t. So we have t cube, so I can write it, I can factorize t cube out, then I have a, then plus 3c, right? Then for the squared, I can factorize t squared out, then I can have b plus 3d. Then also for t, I have this and that, so I can bring t out, then I have 7a plus 4c. Then with t to the power 0, which is just this and that, we have 7b plus 4d as that. Now what we are going to do next is that we're going to find the value of a, b, c, and d. Then after we find this value, we substitute it here. Then after we substitute the values here, then we can finally integrate the integral. But before we do that, if you look at the values over here, you realize that we can compare t cube here to that of t cube here, t squared to t squared, then t to t, then also t to the power 0 to that, right? So we are going to make a comparison over here. Now for the first part, we have negative 12 t cube, this to that, so we have t cube also here, a plus 3c, and we can get rid of the t cube, so we have a plus 3c equal to negative 12, and let's call this equation 1, right? Let's call that equation 1. Then we can have the second comparison also, 6t squared compared to this, so we have 6t squared, then compared to t squared into bracket b plus 3d, so we have t squared cancel t squared, then we have b plus 3d equal to 6, then call this equation 2. Alright, then we have t compared to that, right? So we have t here being equal to t plus 7a plus 4c, t cancel t, then we have 7a plus 4c equal to 1, then call this equation 3. Now for the last part, we have 8 here compared to that, so we have 8 equal to 7b plus 4d, and let's call this equation 4. Now look at the equations. We have equation 1, equation 2, equation 3, and 4. Now if we look at the equations, realize that equation 1 and equation 3 have the same variables of a and c, so I can use that. I can add both or subtract both in order to get the value of a, then also b, d, then so equation 2 to that of equation 4. So now let's start with equation 1 and equation 3. So let's say for equation 1 and equation 3, we have equation 1 as a plus 3c equal to negative 12 as equation 1, then equation 3 as negative 7a plus 4c equal to 1. Now what do we have here? We have a simultaneous equation, and either we use the elimination method or the substitution method. So we are going to use the elimination method. Now using the elimination method, we are going to multiply equation 1 by 7. So we are going to multiply the whole of equation 1 by 7 so that we can add them. When we add them, we can see that 7a plus minus 7a, then a goes away, then we can find the value of c. So we multiply. So I'm just representing the multiplication by this. Multiply equation 1 by 7. So multiplying the rule of equation 1 by 7, we have this 3c, then negative 12 multiplied by 7. So we have 7a plus 21c, then we have 7 times 12, then we have 84 here. So let's call this equation 5. We call this equation 5. So what we are going to do is that we are going to add equation 3 and 5 to see what we are going to get. Okay, so if you look at equation 3 over here, when we made the comparison, t compared to that of t, it is positive, not negative. It is positive, sorry. So we have positive 7a plus 4c equal to 1. So we have positive value here. It is positive. So what we are going to do is that we are going to subtract. So we subtract equation 3 from equation 5. So subtracting equation 3 from equation 5, we have 7a plus 21c equal to 85 here. Then we have 7a plus 4c equal to 1. So we're going to subtracting equation 3. So this is equation 3, this is equation 5, this is equation 3. So subtracting that, 7a goes away, then we have 21 1c minus 4c, we have 17c. Then we have this as 85, we divide both sides by 17, then we have the value of c to be 5. Alright, so now what we are going to do is that we are going to put, so we say put c equal to 5 into into equation 1, so into equation 1, and for equation 1 we have a plus 3c equal to negative 12, so we have a plus 3 multiplied by 5 negative 12, then we have 15 here equal to negative 12, then we have a. Alright, so we have this. Now let's check something. It is negative, so we have negative over here. Then we can have negative 85, because negative 84 negative 1 is just negative 85, so we have c to be negative. Then we have negative 5 here, so we have negative 15. Then we have a equal to negative 12 plus 15, then is equal to 3. Yeah, so we have that. Then also we have to find the value that is for a and c, so we have to find the value of b and d, so we can compare equation 2 and that of equation 4. So let's do that. So we say for equation 2 and equation 4, so for equation 2 and equation 4, we have equation 2 as b plus 3d equal to 6, and equation 4 as 7b plus 4d equal to 6. So this is what we have. Then also we want to use the elimination method over here, so we multiply equation 1 by 7, so we multiply equation, so this is equation 2 and this is equation 4, so we multiply equation 2 by 7, so the whole of equation 2 by 7, we have 7b plus 21d being equal to, then 42. Alright, so now we have so let's call this equation 6. Now what we are going to do is that we are going to compare it to equation 4, so we subtract equation 4 from equation 6. So subtracting that, we have equation 6 as 7b plus 21d equal to 42. Then we have 7b plus 4d equal to 6. This is equation 6 and this is equation 4. So we subtract, this goes away, then we have this as 17. We have equation, so we have 17 equal to now equation 4 was this. Equation 4 is 8, 7b plus 4d equal to 8. So this place equation 4 here should be 8. So that 42 minus 8 is just 34. Then we divide both sides by 7 is d. So we divide both sides by 17, and we have d here being equal to just 2, being equal to 2. Then what we are going to do next is we're going to put d equal to 2 into equation, so equation 2 is good, so because we have b plus 3d equal to 6, so we have b plus 3 then multiplied by 2 equal to 6, then we have 6 here, 6, and b equal to 6 minus 6 equal to 0. So we have the value of b equal to 0. So therefore we can have that a, we had the value of a the value of A as 3, the value of B as 0, C as -5, and also D as 2. So these are the values we add. So we are going to put this back into the general equation over here, this equation over here. So we are going to put the value of A, B, C, and D back into it. So we have 8 plus t plus 6t squared and minus t cubed being divided by 3t squared plus 4, then t squared plus 7 here. So we're going to replace it now. Okay, so let's write the old thing, then we can replace it. So we have this plus ct plus d here all over t squared plus 7. So from here we have 8 plus t, so just this whole thing again, and 3t squared plus 4 here, and t squared plus 7 being equal to, now the value of A is just 3, so we have 3t, then the value of B is 0, so it goes away. Then we have 3t squared plus 4 just here. Then we have C is -5t, so let's put 5 here, so we have -5t, and D is 2, so plus 2, then divided by t squared plus 7. Now we've gotten our value now. So now what we're going to do next is that we integrate now. So we integrate. So we now integrate. So the integral of the whole of this 6t squared minus 12t cubed, then divided by 3t squared plus 4, then also t squared plus 7 here, just the integral of 3t t squared plus 4, then also, so we can have dt, then -5t plus 2 all over t squared plus 7 here, let's put them in a bracket, then dt, then let's continue here. So we have, so over here we have the whole of this, so just let's integrate from here. So integrating this, we have, so we can have this 3t squared plus 4. Now let's separate them so that we can also have -5t over t squared plus 7, then dt, then also the integral of 2 over t squared plus 7 dt. So what I just did was to, we are going to differentiate them one after the other, because differentiating the whole of this is a bit complicated. Now from here we apply the substitution method. So by substitution, we say that let this u equal to 3t squared plus 4 for this part, so that the u, the t here will be equal to, so we are differentiating this, which is this 2 multiplies 3, 6, then we subtract 1 from here, which is just t, and the constant goes away. Then also by substitution over here we have t equal to t squared plus 7, then du dt is just 2t, and the constant goes away. So you realize that we have our integral in dt, so we're going to replace it. So just dt here is just equal to du over 6t, then also d, so it's dt here is just du over 2t, right? So we're going to replace the values over here. So we have the integral of 3t, then we have u, because 3t squared plus 4 is just u. Then we have multiplied by dt, so dt here is just that, so we replace it by du over 6t. Then we have the next one, which is negative 5t, then over u, then multiplied by dt, and the dt here is just this, du over dt. Now for this part, if we put u over there and we integrate, you can see that we still have the t still in the integral. Meanwhile, we are integrating with respect to u. So let's leave it this way. We are going to apply a trig substitution over here. So let's leave it this way for now. Then t cancel t, goes here 1, then goes here 2. So we have 1 over 2 outside, then we can have 1 over u, then du plus, so we have it is du over 2t, so t cancel t, and we have negative 5 over 2 outside, and we have 1 over u, then du over here. Then over here we have a trig substitution over here. Now tan is just the tan inverse of x is just 1 over 1 plus x squared. So if that is the case, then we have to write this in the form of a tan inverse. So we have so we divide here by 7, then we can have t squared divided by 7, then 7 divided by 7, because we are doing this because we want to write the whole of this in terms of tan inverse. So over here we have 1 over 2, then 1 over u du is just the ln of u, then minus 5 over 2, then the ln of u again. Then over here we have 2 over 7, then we have t squared over 7 plus 1, then still with dt. So we can now it is in the tan inverse form, so now we can integrate it now. So we have this as 1 over 2, then the ln of that is just u here is just 3t squared plus 4, then minus 5 over 2, then we have the ln of u here is just t squared plus 7, then with this we just have 2 over 7 out, then the whole of this will now look like 1 over that, so it's just the tan inverse of t over 7 over here, then plus c, then plus c, then so we can have this, so that finally we can get our final answer as 1 over 2, the ln of 3t squared plus 4, then minus 5 over 2, then the ln of t squared plus 7, then 2 over 7, the tan inverse of t over 7, then plus c. Remember, it is in the tan is the square root, so we add it to it. And thank you very much for joining me in this section, and I hope this section was helpful. I will see you in another section.